Hey everyone, welcome back, and today let's solve Leetcode problem 3163 titled String Compression 3, the daily Leetcode challenge problem for today. So we're given a string word and we need to compress it using the following algorithm. We first begin with an empty string comp, and while the word is not empty, we can use the following operation. We want to first remove a maximum length prefix being the keyword, of word made of a single character C, repeating at most 9 times. And then we want to append the length of the prefix followed by C to the comp, and we want to return the string comp. Okay, so in example 1, we have the input word string to be A, B, C, D, E, and we get something like this for our comp string result. We get one A, we get one B, we get another C, we get a D, and we get one E. Why? Because initially our comp is equal to an empty string, and if we apply this operation 5 times, we'll use A first for the initial prefix, then we'll have the second prefix B, and then C, and then D, and then E as each prefix in each operation. We can't have A and B as one prefix because, of course, A is not equal to B, and so they're their own separate prefixes. All right, and for each prefix, we want to append 1 because that's the number or length of the prefix at that iteration to our comp string. Okay, so in example 2, we have the input word string to be the following. We put 9 A's, and then 5 A's, and then 2 B's. Right? Why? Again, similar approach. We have a comp initialized to an empty string. If we apply this operation 3 times, we'll have 9 A's. Why don't we have all 14 A's just like this? Because we know that we can only have at most 9 repeating characters for each prefix. Once we hit 9 A's, that maximum limit, we want to move on to the next A, or the next batch of A's, so the next 5 A's. And we can't keep going for these because these are B's, they're different than A. So once we hit the last A, we'll stop, we'll move on to B's, and then we have 2 B's, so we'll output 2, and then B. Okay? So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and to think of a valid solution. And then I'll show you guys how I would optimally solve this problem in a few seconds. Alright, sorry about that, guys. I realized I was talking a little bit too fast. I'll try to slow down for the rest of the video to make my solution and my thought process a little bit more understandable as we go. Okay, so how do we want to kind of structure this problem? First of all, I don't really like appending and deleting characters from strings, because first of all, strings are immutable data structures, and they're not very fun to work with after creating them or initializing them. So I'm going to have my initial comp, or I'll just call it result for more readability and better to understand. And it's going to be initialized to a list. And in Python, there's a very nice built-in feature that I can use. So first I'm going to have my result. And this is going to be equivalent to my comp, and it's going to be initialized to an empty list. And effectively, once I'm done populating this result, I simply want to return the string of the result, which is just using the string.join feature in Python of our result. What does this do? It simply concatenates all the separate characters in the result and joins them, right, like as you see right here, into one single string, right? We have to string.join all these characters in the result iterable into, well, one string. But that's only after we're done populating this result. Till we do that, now we actually have to process and kind of parse through our input string. Okay, so what are we going to do first? Okay, first I'm just going to initialize my pointer I and set it equal to 0. And what is this really going to do? It's simply going to act as a pointer that we're going to use to traverse through each character in our word, right? Our input word string. And technically my next line is kind of unnecessary. I just want to do this for easy access. I'll set n equal to the length of the word. So it's a little bit easier to access it instead of having to type length of the word each time I want to access this value, right? And then we'll have while, our main while loop in this code, right? So while our I index, while that's less than n. What does that mean? While we actually do have processes, or rather, while we actually do have characters to still process, so while our index for this current prefix is still in bounds of the input string, then in that case, for each iteration, we can set j equal to I plus 1. What is j? It's simply going to be the pointer to help us find sequences of repeating characters by comparing word at j with word at I and shifting to the right as we see these prefixes that have the same characters. It's simply our shifter or our second pointer in a way. Okay, so now we'll have another big while loop here. So while j is actually less than n. What does this mean? While j is in bounds, it's still less than the length of the word, the input string word, and it's not going out of bounds. And word at that index j is still equal to word at I. What does that mean? While the current index, or rather character that we're looking at, is still equal to that word at I, because we know that we need to make sure that it has to be of the same character, right? It says remove a maximum length prefix of word made of a single character C, or basically the same character C that repeats at most 9 times. So while the word at J is equal to word at I, so while we have the same single equal character, we can kind of shift our window or expand our J pointer also while it's still in bounds of our input string. So while that's still true, we can set our current count to be equal to J minus I, right? This is just going to give us the number of times that word at I actually does repeat consecutively, right? The length of the current window, or rather the current prefix that we're computing in this iteration. Okay, so once we have that, now, while our count is greater than 0, so while we actually have a count that's greater than 0, what does that do? It simply allows us to handle counts that are larger than 9 by breaking them down into smaller groups of 9 or even less. So while that's less than 0, so while our count is less than 0, we'll set, so this is pretty smart here, we'll set our length equal to the minimum value of the 9 and our count. Why? So we know that our character C can repeat at most 9 times in this window, or this current prefix, right? And we have to set it to the minimum because we want to group the repeating characters in chunks of 9 at most, or fewer if possible. And if the count is actually more than 9, then the length would be set to 9, right? Which would and we'll handle the rest in subsequent iterations, right? So this is going to make sure that even if we have a count or window size that's greater than 9, we're going to default or go to the minimum of 9. And of course, if a count is less than 9, we just hit that value instead. If it's equal to 9, well, it doesn't really matter. The minimum of 9 and 9 is just 9, and either way, we're going to get 9 as an output. So once we actually calculate our length, we want to add that corresponding character and its corresponding window or prefix length to our comp result, or rather our result array. So we'll say result.append in Python, and I'm going to use a formatted string here, or an F string. It's a little bit Pythonic, but it's pretty straightforward here. It's also a built-in feature in a lot of other languages as well. So we have to say F, and then the formatted string will have, and then curly brackets for formatted strings in Python, will have the length first, because as you can see in example 1, we want the length of the prefix before the actual repeating character. So the length, and then we want to actually have the current character. And how do we get the current character? It's simply just word at that index I, right? The word that's repeating in this current prefix, right? And once we do that, now we can simply decrement our count by length. So count minus equals the length, because we have to reduce the remaining count of this character, which is going to allow us to handle cases where that character actually does repeat more than 9 times by adding multiple entries to our result. And then we want to set I outside of this while loop to J, right? It's going to basically move I to the start of the next new character sequence in the next prefix of future iterations. And ultimately, we can just return the string.join of result, because it's going to, again, combine all of the elements in the result into that single string and effectively return it, which is going to be the compressed string of our word, right? We want to return a string of these numerical digits and corresponding repeating characters. And as you can see, unless I made any syntax errors here, this should be accepted and this should be a valid solution. Okay, let's see what I did wrong here. Okay, we have J plus 1. Okay, yeah. Don't know why. Oh, oops. Oops, forgot to increment J by 1 here. Sorry about that. And then we want to set count to be equal to J minus I. And now this should work. Sorry about that, guys. Quick error. But now this is going to be an accepted solution. And as you can see, it is just about as efficient as you can get. Sorry, I forgot to actually compute our count, or the length of our current window in this while loop. And I simply forgot to increment our J pointer by 1. It stayed the same. And so that was my bad. But this is how the code solution looks. It's pretty efficient. And what does it do overall? Kind of just to reiterate, what does this actually do? So basically, we're going to compress the string by basically grouping consecutive characters and adding each group as a number character of pairs to that result list. And if a character appears more than 9 times in a row, we're going to split it into multiple groups of 9. And then we have to effectively just join that result into a single string and return it as a group of compressed strings, or rather one complete compressed string of every single prefix or window size and its corresponding repeating character. So for the time complexity of this code, this is going to be big O of n, or a linear time solution, because we're really only iterating over the string only once. And the space complexity is also going to be big O of n, or linear, because we are actually storing the compressed segments of our string into that return list, which in the worst case could be about as long as that original string. And that's going to be about it. If you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.